This video is based on an article originally printed in Advance magazine and was written by Greg Cooper. A link to the original article is provided in the video description. Medical laboratory process control is about to change. Later this year, when the Centers for Medicare and Medicaid Services updates the interpretive guidelines for CLIA compliance, they're expected to unveil the new Individualized Quality Control Plan, IQCP. IQCP will give laboratories the opportunity to customize the frequency of QC based on a documented risk assessment. In addition to the typical focus of risk assessments, potential process and instrument failures, a laboratory risk assessment must also look at lab operations for contributors to risk, such as the source and type of control material used by the laboratory. There are typically two sources of control materials: the instrument, kit, or method manufacturer, manufacturer-supplied controls, and manufacturers of control materials, independent or third-party controls. The risk associated with using manufacturer controls has been present for decades. For example, in the 90s, one of the first troponin assays was introduced with the manufacturer providing its own control material. Labs running the manufacturer's control observed unexpected swings in patient test results, but the manufacturer's control consistently performed within expectation. Conversely, those laboratories that were testing a third-party, independent control saw variation in these controls, along with variation in patient samples. Customer calls ultimately led the manufacturer to identify and correct an instrument problem. But in the meantime, labs using only the manufacturer's controls reported troponin values that were not reliable, putting patients at risk. Risk associated with using only manufacturer-supplied control materials is now globally recognized and discussed by national organizations and regulators. Control materials from the two sources just identified are further characterized into three types: dependent, semi-dependent, and independent third-party controls. Each has a risk profile. Dependent control material is a quality control material manufactured under the same quality system as the instrument, kit, or method it's intended to monitor, and whose performance depends on design inputs from the instrument, kit, or method manufacturer. Independent third-party control material is manufactured outside the quality system used to manufacture the instrument, kit, or method it's intended to monitor, and whose performance is independent of any design inputs from the instrument, kit, or method manufacturer. Quality control material, assayed or unassayed, is a medical device intended for use in a test system to estimate test precision and detect systematic analytical deviations that may arise from reagent or analytical instrument variation. Semi-dependent control material is manufactured outside the quality system used to manufacture the instrument, kit, or method it's intended to monitor, but is manufactured on behalf of and with input from the instrument, kit, or method manufacturer. Let's look more deeply at dependent, semi-dependent, and independent controls. Dependent controls are typically provided by the instrument manufacturer. This type of control material also includes what's referred to as in-kit controls. Those control materials provided as a part of a discrete test kit. Dependent control materials are often manufactured from the same lot of raw material, using the same manufacturing process, and made in the same facility used to manufacture the instrument, kit, or method calibrators. At some point, the manufacturing process for controls and calibrators splits. The extent that the controls and calibrators share manufacturing processes determines the degree to which the control materials will act like the calibrators. The main associated risk is the inability to reliably detect performance shifts or subtle changes because the controls are insensitive to the change, acting more like calibrators or having been otherwise optimized to work on the instrument or with the kit method. In such situations, the risk of harm to the patient can be substantial. Calibration between instrument and control manufacturers is a more recent occurrence, and the term semi-dependent as it relates to control material is not widely found in literature. The uniqueness of these calibrations provides an opportunity for greater risk if not addressed in selecting control materials. Semi-dependent control materials are those materials that are made by a control manufacturer on behalf of an instrument, kit, or method manufacturer. The fundamental qualifying characteristic for semi-dependent control materials is the manufacturing relationship between the instrument manufacturer and the manufacturer of the control material. When the instrument manufacturer provides exacting specifications for the control materials, such as stabilizers and preservatives, or the instrument manufacturer provides manufacturing instructions for optimization of the control materials, so the materials will work reliably and consistently with the instrument, kit, or method, or any combination of the above. The risk associated with semi-dependent controls can be similar to the risks associated with dependent control materials if the controls are manufactured in such a way that the sensitivity to performance variation is compromised. Risk also derives from the fact that semi-dependent controls are invisible, because the formulation of the control material is usually not revealed in product labeling. The laboratory is typically unaware of the manufacturing relationship or of any optimization or special product specifications that might have occurred with the material. For example, a semi-dependent control could be mistaken for a dependent control if the instrument, kit, or method manufacturer labels the control material with their own logo, but does not reveal the control was made by some other company. On the other side of the coin, a semi-dependent control may be identified as such by the instrument, kit, or method manufacturer without revealing the material has been optimized to work with its instrument, kit, or method. Either situation may lead to risk of harm to the patient if the instrument begins to malfunction, or has malfunctioned and the control does not identify it. Risk of harm increases as the laboratory continues testing, unaware a problem exists with the instrument or kit method. The most reliable monitor of instrument performance is provided by independent controls. The key differentiating characteristic is that they're designed and manufactured free of any instrument, kit, or method manufacturer involvement. Independent control materials have the lowest risk profile because they work with multiple methods and instrument platforms. They can often readily detect changes in reagents, instrument integrity, and calibration. The following are 3 tables that allow you to make some comparisons. We recommend that you pause the video to review the content. This chart compares the offerings of control manufacturers. This chart compares the offerings of instrument manufacturers. Here you can see the anecdotal risk profile of quality control materials. The chart denotes high, medium, and low risk for each characteristic. For all of your laboratory QC needs, visit www.qcnet.com.